Hello friends, welcome to IFL Academy. Today we will study the chapter Height and Distance of Trigonometry of class 10th. Very easy, very interesting chapter and very important from exam point of view. In this chapter, we will see how trigonometry is used for finding the height and distance of various objects without actually measuring them. For example, the height of a tower, mountain, building or tree, distance of a ship from a lighthouse, width of a river, etc. can be determined by using the knowledge of trigonometry. This is the Burj Khalifa Tower of Dubai, world's tallest tower. Suppose we want to find the height of this tower, this height of tower. So by using the concept of height and distance of trigonometry, we can easily find the height of this tower. Now let us study some basic terms which will be used in this chapter. The first term is line of sight. What do we mean by line of sight? The line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. See the figure. Suppose this is the Qutub Minar of Delhi. A pigeon flies off and sits on the top of Qutub Minar. Suppose this is the observer standing here. This observer is me. This observer is looking at the pigeon on the top of Qutub Minar along this line. So this line will be called line of sight. Next term is angle of elevation. Very important. Angle of elevation is the angle formed between the line of sight and horizontal line when we look at the object on the top from the ground. See the figure. Suppose observer is looking at the pigeon. Pigeon is the object. Observer is looking at the pigeon on the top from the ground along the line of sight. This is the horizontal line. So this angle between line of sight and horizontal line is called angle of elevation. This angle. So whenever we look at the object on the top from the ground, so the angle formed between line of sight and horizontal line is called angle of elevation. Now let us solve one example on angle of elevation. The question is, there is a flag staff on a tower of height 20 meter at a point on the ground. The angles of elevation of the foot and top of the flag staff are 45 degree and 60 degree respectively. Find the height of the flag staff. So what the question is saying, one flag staff is on the top of a tower of height 20 meter. Okay. So from the point on the ground, the angle of elevation of the foot of the flag staff is 45 degree and angle of elevation of the top of the flag staff is 60 degree. So we have to find the height of the flag staff. So first of all, let us draw the figure. Suppose this is the tower. This is the tower of height 20 meter. This is the flag staff on the top of the tower. Now let us consider a point P on the ground. From this point P, the angle of elevation of the foot of the flag staff is 45 degree. This angle is 45 degree. And also from this point P, the angle of elevation of the top of the flag staff is 60 degree. This angle is 60 degree. So we have to find the height of this flagstaff QR. Let us assume the height of flagstaff QR is h meter. This height. This angle will be 90 degree. Tower stands vertically above the ground. So now in right angle triangle RSP, in right angle triangle RSP, tan 45 degree will be equal to perpendicular upon base. Perpendicular is 20 upon base is PS, and the value of tan 45 degree is 1. So this will be equal to 1, cross multiply. So 20 will be equal to PS. So the value of PS is 20 meter. Now in right angle triangle QSP, in right angle triangle QSP, tan 60 degree will be equal to perpendicular upon base. Perpendicular is QS upon base is PS. See one thing, the line adjacent to the angle is called base and the line opposite to the angle is called perpendicular. So in right angle triangle QSP, for angle 60 degree, opposite side is QS, so QS will be perpendicular, and adjacent side is PS, so PS will be base. So tan 60 degree equals to perpendicular upon base. The value of tan 60 is root 3. So this will be equal to root 3. And what is the value of PS? PS is 20. So QS upon PS value 20. Will be equal to root 3. So the value of QS is 20 root 3. And what is QS? What is QS? QR plus RS. QS is QR plus RS. What is the value of QS? 20 root 3. Put here. Is equal to QR. What is QR? H. QR is H plus what is RS? RS is 20 meter. So H plus 20. So H will be equal to 20 root 3 minus 20. Take 20 common. In bracket it will be root 3 minus 1 meter. So the height of the flagstaff is 20 into in bracket root 3 minus 1 meter. So this question is solved. Height of the flagstaff was h, we assumed. Then comes the third term, that is angle of depression. It is the angle formed between line of sight and horizontal line when we look at the object on the ground from the top of the building or tower. See the figure here. Suppose observer is standing on the top of the building and the object, that is football, is lying on the ground. So observer is looking at the ball along the line of sight. This is the horizontal line. So the angle between this horizontal line and line of sight, this angle is called angle of depression. So whenever we look at the object on the ground from the top of the building or tower, then the angle formed between horizontal line and line of sight is called angle of depression. Now let us solve one example on angle of depression. The question is, an aeroplane is at an altitude of 1200 meter. The two ships are sailing towards it in the same direction. The angles of depression of the ships as observed from the aeroplane are 60° and 30° respectively. Find the distance between the two ships. Okay, so first of all, let us draw the figure. Suppose this AB is the tower and suppose the aeroplane is at the point A, which is 1200 meter above point B. This AB is 1200 meter. Now consider two ships at points P and Q. Okay, so the angle of depression of ship at point P from the point A will be this one. Draw a horizontal line. This is the angle of depression of ship at point P from point A. Okay, and angle of depression of ship at point Q from the point A will be this one. Bigger angle is 60°, so this bigger angle will be 60°. Smaller angle is 30°. This smaller angle will be 30°. And we know that alternate angles are equal, so this is 60, so this will be 60°. Alternate angles. This is 30, so this will be 30°. Alternate angles. So what we have to find? We have to find the distance between two ships, that is PQ. PQ we have to find. Okay, this angle will be 90°. Now in right angle triangle ABQ, in right angle triangle ABQ, tan 60° will be equal to perpendicular upon base. Perpendicular is 1200 upon base is BQ. Tan 60° is √3. This is equal to √3. So BQ will be equal to, cross multiply, BQ will be equal to 1200 upon √3. Then rationalize the denominator, multiply numerator and denominator by √3 into √3 upon √3. This will be equal to 1200 √3 upon √3 into √3, 3. Now cancel 1200 by 3. 3 ones are 3 fours are 00. So BQ is equal to 400 √3. Here we have used the concept of rationalization of denominator. Whenever irrational number is in denominator, then rationalize it, so the calculation will become easy. So BQ has come 400 √3. Now in right angle triangle ABP, in right angle triangle ABP, tan 30° will be equal to perpendicular upon base PB. Tan 30° will be equal to perpendicular. What is perpendicular? AB upon base PB. AB is how much? AB is 1200 upon PB. The value of tan 30 is 1 upon √3. So this will be 1 upon √3. Cross multiply. So PB will be equal to 1200 root 3. Okay, so we have found BQ and PB. Now PB is what? PB is what? PQ plus BQ. PB is equal to PQ plus BQ. Now put the values. PB is 1200 root 3 equals to PQ. PQ we have to find out. PQ plus BQ. BQ is 400 root 3. 400 root 3. So PQ will be equal to 1200 root 3 minus 400 root 3 will be equal to 12 minus 4 8. 800 root 3 meter. So the distance between the two ships, that is PQ, is equal to 800 root 3 meter. This question is solved. Now please note down some important points. The first point is, from a given point, when height of an object increases, the angle of elevation increases. Means what? Suppose this is the given point C, and firstly the object is at height h2. Here the object is. When the height of the object is increased, now the height of the object is h1. Now the object is at this point A. So the angle of elevation of the object will also increase from the same point C. Firstly, the angle of elevation was alpha. Now it has increased to angle of elevation beta. So firstly the angle of elevation was beta. Now it has increased to angle of elevation alpha. So alpha is greater than beta. So whenever the height of the object is increased from the same point, so angle of elevation will increase. Second point is very important point. The angle of elevation increases as we move towards the foot of the vertical object, like tower or building. Means what? Whenever we move towards the foot of the tower or building, the angle of elevation gets increased. Like here, from C to point B we are moving. Suppose B is the foot of the tower or building, so the angle of elevation will increase. Firstly it was alpha, then it has become beta. So alpha will be less than beta, or beta will be greater than alpha. Very important point. Remember this point. It will be helpful in solving the questions. So whenever you move towards the foot of the tower or building, the angle of elevation gets increased. Next topic is combination of angle of elevation and depression. In some problems, angle of elevation and depression both are included. So let us solve one example on this topic. The question is, from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degree and the angle of depression of its foot is 45 degree. Find the height of the tower. So first of all, let us draw the figure. Suppose this is the tower AB and this is the building CD. Join DB and through point C draw a horizontal line parallel to DB. Okay. Now from point C, the angle of elevation of the top of the tower is how much? 60 degree. This angle is 60 degree. And from the same point C, the angle of depression of foot of the tower is how much? 45 degree. this angle is 45 degree, and we know that alternate angles are equal, so this angle will be also 45 degree. And the height of the building is given how much? 7 meter. When this is 7, this will be also 7, because DBEC is a rectangle. This angle will be 90 degree, this angle will be also 90 degree. Okay, so what we have to find? We have to find the height of the tower AB, this height. Okay, now come in triangle this, in right angle triangle CDB. In right angle triangle CDB, tan 45 degree will be equal to, why we are applying tan? Because we see here perpendicular is given and we want this base BD, so tan theta is equal to perpendicular upon base, that's why we are using tan here. So tan 45 degree will be equal to perpendicular upon base, perpendicular will be 7 meter upon base will be BD. As we know that the side opposite to the angle is perpendicular and the side adjacent to the angle is base, and tan 45 is 1, so this is equal to 1, cross multiply, so BD is equal to 7. BD has come 7. When BD is 7, then CE will be also 7, because opposite sides of rectangle are equal, so this will be equal to CE. Now in right angle triangle AEC, this triangle, in right angle triangle AEC, AEC, again apply tan 60 degree. Tan 60 degree will be equal to perpendicular AE upon base CE. CE is 7, so tan 60 degree will be equal to perpendicular. Perpendicular is AE upon base. Base is CE. The value of tan 60 degree is √3, and AE we don't know, CE is 7, CE 7, so AE upon 7 will be equal to √3, so AE is equal to 7 √3. Now see here, what is AB? AB we have to find. AB is AE plus BE. AB is equal to AE plus BE. Put the values. AE is 7 √3 plus BE is 7. This one BE is 7. Take 7 common. 7 into in bracket √3 plus 1 meter. This is AB, and AB is the height of the tower. So height of the tower is 7 into in bracket √3 plus 1 meter. So I hope whatever is taught is very much clear to you. That's it in this lecture. Now we will meet in the next video lecture. Thank you.